Welcome everyone. My name is Kristin Burmeister. I am a postdoc at the Scottish Association for Marine Science in Oban and in the iAtlantic project. Last year in October, I attended my very first OSNAP cruise on the research vessel Discovery in the Subpolar North Atlantic, one of the roughest seas in the world. My most favorite moment happened at the end of the cruise when Discovery dropped us off of my host institute, SAMS. What I find so fascinating about it is that there are important climate-relevant ocean observations happening on our doorstep. And today I want to explore the bigger picture with you. Therefore, my wonderful colleague Sas and me interviewed some of the scientists and technicians of our cruise. I really hope you enjoy it. And before we start, Sas, can you tell us more about you and our institute?
My name is Saz Reid. I am the Ship's Operations Manager and Research Technician for SAMS. For that research cruise, I was the chemistry technician, so I was doing oxygen calibrations for all the sensors. So a bit about SAMS. So SAMS is an independent academic partner of the University Highlands and Islands. It was founded in 1884 by Sir John Murray. What do we do? So we research how the marine environment works and how it's changing and why. Why do we do it? Because we would love a healthy and productive sea and ocean that supports life on our planet and continues to provide us with resources. How do we do it? So we undertake research in all aspects of the marine system. And one of the ways we do it is by the OSNAP programme and the research cruise.
Thank you, Sas. Our first guest is Professor Stuart Cunningham, who spent several years at SEAS and is one of the initiators of the OSNAP project. Stuart, can you explain what the OSNAP cruises are and why they are important?
Good morning, Christine. Thank you very much for having me. Well, a fundamental prediction of climate change models in the 21st century is a slowing of the Atlantic circulation. And we do know that this will likely have profound impacts on global and regional climates. OSNAP measures North Atlantic ocean circulation and ocean properties to better understand if these climate model predictions are accurate, if the situation is better or worse than forecast, and perhaps most critically to try and inform the risk posed to ecosystems and societies if Atlantic circulation is near a climate tipping point, which could rapidly and radically change long-established climate patterns. The cruises are really part of a huge multinational programme to ensure this precious time series of observations of Atlantic circulation is maintained uninterrupted.
Thank you. You're also involved and train early career ocean professionals during such cruises. Can you tell us why and how you do it?
I've had maybe over 30 cruises that I've led as chief scientist. And in the end, I've actually spent several years of my life afloat on research ships in the Southern Ocean, the Atlantic, and the Pacific and the Indian Oceans. And it's a really exciting and satisfying way to spend your life. I mean, I have worked with so many fine and very clever oceanographers all over the world that I can only hope to encourage others in such a career. How I do this is by recruiting the best young scientists and giving them responsibility and space to develop their careers. And so I have to work closely with young scientists at sea because it is such a high pressure and highly rewarding workplace. We're here to generate the new knowledge that will help us through the current climate emergency. One of the core objectives I particularly like in the Ocean Decade for Sustainable Development is to improve the scientific knowledge base through capacity development. We can offer fast-track routes into our experience that could be transformative when those skills are shared around the world.
Thank you so much, Stuart. And now we have our next cruise participant, Sam Jones. He is a physical oceanographer working with gliders. So Sam, during our cruise, we had a glider race going on. Could you tell us a little bit more about it?
Yeah, the race between Discovery and the glider came about by accident, actually. The ship was moored in Southampton and we had to wait a couple of weeks so the scientists and crew could quarantine before sailing. Meanwhile, the glider was launched in the Inner Hebrides and flown westward to start its mission. So the glider only had to travel 100 kilometers, whereas Discovery had to sail all the way around from Southampton, around Land's End and up through the Irish Sea. But Discovery is maybe 20 times faster than the glider, so it was a bit of a tortoise and hare race to the EB1 mooring.
Yeah, but what was the glider doing out there?
So the North Atlantic is a very hostile place for scientific instruments. It's quite difficult to get to. There are huge storms through the winter, and fishing activity can damage moorings as well. There's one current that's proved particularly hard to sample. It's called the slope current, and it's a narrow focused stream of water flowing northwards along the edge of the continental shelf. We can't put a fixed mooring there because there's a lot of fishing activity and it'll get destroyed. So that's where the gliders come in. We pilot them out to the region and we fly them back and forth across the current. They don't mind rough weather. They're less at risk of fishing, and I guess importantly for this year, you can pilot them from your computer at home. So they're socially distanced science.
Thank you so much.
Hello, Lewis. As our early career ocean professional who's working at SAMS as a robotics technician, we would love it if you could briefly explain what deep sea moorings are and what they are showing and why it is important.
Hi, Saz. Thanks so much. A deep sea mooring is essentially a long vertical line in the ocean with many sort of high accuracy ocean instruments placed at intervals that best sample the physical and chemical properties of the water. The mooring is anchored to the seabed using an acoustic release system, and this means that you can retrieve the instruments at a later date, typically 1 to 2 years after deployment. Our mooring data show us the temperature and salinity structure of the water column, as well as the current velocity. From this, we can make estimates of fluxes of heat and fresh water in the area. But in general, the moorings allow us to build up a long-term record of ocean water properties, which contribute to the understanding of these changes of properties over sort of longer timescales.
So how do you do data control on a research cruise, including data distribution afterwards?
The real-time data processing takes place on the ship, allows us to see how the instruments have performed during the deployment. And this may include the calibration of sensors with seawater samples or comparison with very high accuracy profiling instruments that we use on the ship. Corrections for sensor drift and the interpolation of missing data and spike identification are part of the sort of delayed mode processing, and that's carried out once back ashore. Data is then distributed to our project partners and to international ocean observing networks, oceanographic data centers.
Oh, thank you so much for speaking to us and answering all our questions. Hello, Claire, our early career ocean professional, who is now a postdoc on the iAtlantic programme, which is a programme linked closely to OSNAP. So could you tell us what is the importance of moored biogeochemical sensors?
So ocean currents transport vast amounts of carbon and nutrients, and moored biogeochemical sensors allow us to see how this varies with time. In the ocean, you have these microscopic plants called phytoplankton, and just like your house and your garden plants, they need nutrients in order to be able to grow. And phytoplankton actually, they take up carbon dioxide in the atmosphere. When they die, they sink, and this carbon dioxide is trapped in the deep ocean or sediment. So they remove carbon dioxide from the atmosphere. So nutrients and carbon in the ocean is really important for global climate.
So what is your favourite thing about being a postdoc?
So different things. So I can't go to sea at the moment because of health conditions. So I provide shoreside support for cruises and communicate with the ship daily. I really enjoy that. And just finding out new things, like we don't know how much nutrients and carbon is transported by these currents at the moment. So being the first person to find that out is kind of cool.
Yeah, fantastic. Yeah, I love your passion about it, and you're a fantastic shore support. And we couldn't do it without shore support and all the preparation of a cruise. So no, it's super, super great. Well, thank you so much for answering these quick questions, and see you soon.
Thank you everyone to listening what we were up to on our OSNAP cruise in the North Atlantic.
We had such a great time interviewing our colleagues about how our research cruise and the OSNAP programme fits into the UN Ocean Decade and how important development of early career ocean professionals are to the success of a research cruise.